Welcome to iLecture Online, and today we're going to show you how to do some derivatives, and we're going to start with some simple ones. Here are the simple ones, and just to remind ourselves how to do these, here are the basic formulas or basic techniques that we want to apply or use for these kind of examples. All right, so looking at our first one here, we have y equals 3x to the fifth power. Looking over here, we know that when we have a constant in front of x to the n power, we just simply leave the constant there and take the derivative of x to the n, which we can show you there. That's how that's done. So looking at this problem and looking at the general example there, we can then say that y prime, which is equal to the derivative, the d dx of y, is equal to 3 times 5. We bring down the exponent, times x to the exponent minus 1. And so this is equal to 15x to the fourth power. So again, the rule is that you bring the exponent down, you multiply it with a constant, and then you subtract 1 from the exponent. Okay, looking at the second one, excuse me, and applying the same rule, we have y prime, which also means the d dx, the derivative with respect to x of y, is equal to, again, multiply the constant times the exponent, so we have minus 5 times 15 times x to the exponent minus 1, 15 minus 1, so this is equal to minus 75 x to the 14th power. All right, some good examples of how to apply those rules. Do one more here. Now you say, well, wait a minute, how does it work when you have a negative exponent? Well, it actually works exactly the same. So you have y prime, which is the same as saying the d dx of y, which is the derivative of this. So again, you bring the exponent down and multiply times the constant. So it's minus 4 times minus 5 times x to the exponent minus 1. That rule hasn't changed, even if it's a negative number. And so this is equal to 20x to the minus 6th power. We could write it like this. We could say, well, this is equal to 20 divided by x to the 6th power. Either way, same answer. All right, one more here. Now you can see that this is the sum of two terms. And before we take the derivative here, we're going to rewrite this with x in the numerator and a negative exponent. So we rewrite this problem as y is equal to 3x squared plus x to the minus 1 power, which is the same as what we have over there. And now we again employ the rules that we have here to the side. So we can say that y prime, which is the same as saying the d dx of y, is equal to, we bring the exponent down, so we have 3 times 2x to the exponent minus 1, plus, we bring the exponent down, a minus 1 times x to the minus 1 minus 1. We subtract 1 from the exponent, regardless if positive or negative. So this then becomes 6x to the first power minus, we don't have to write a 1, x to the minus 2 power. And then to simplify things, we can get rid of it to the first power and bring this down to the denominator. So this is 6x minus 1 over x to the second power, and that's the proper way of writing the final answer. So here's some good examples of how you take simple derivatives of functions that look like this. So here's our first one, there's our second one, there's our third one, and then even though we have written it like this, this is really two of these terms together that look like that. And again, for summary, you can say that you take the exponent, multiply times the constant, and then subtract from the exponent. Take the exponent, multiply times the constant, subtract 1 from the exponent. Take the exponent, multiply times the constant, subtract 1 from the exponent. Take the exponent, multiply times the constant, subtract 1 from the exponent. And so that's how you do these problems. All right, those are the easy ones. We got some that are a little bit more difficult, so stay tuned for the next session and see how those are done.